Right, today we're going to talk about 3.5 practice, things every graph must have. This is basically talking about what a graph needs to look like, stuff like that. It needs an appropriate descriptive title, so it needs a title, the horizontal and vertical axis labeled, with the units measurements when needed. 3, so depending on if it's measuring by dollars or cents or whatever. Sources, especially when presented in media, appropriateness for the data being presented. So a bar graph versus a line graph versus a pie chart. So making sure it's using the right kind of graph. 5, appropriate scaling should always start at 0. All right, so looking at this graph here, what issues do you see presenting at the graph? Well, the last one, number 5, it says it should always start at 0, but we don't. On our y-axis, we do not start at 0. So y-axis, it does not start at 0. That's a problem. So, and if you look at it, the scale is too drastic. So like 2006, 2000, it's just all over the place. So scale is too drastic. Okay. Moving on, number 2, the U.S. median home price increased by 219,600 in November to 318,700 in November 2017. So 2010 to 2017, as shown in the pictograph. What was the percentage increase in median homes? So we want the percent increase. So we want the change over the original. So the change would be 300, so I'm going to do parentheses 318,700, and we're subtracting that from the original, which is 219,600, and then we want to put it over the original price it was, so 219,600 again. And so the percent, and then I'm going to change this to percent by going to general and switching it to percent. About 45.13 or 45%. Is the pictograph shown an accurate description of this increase? Well, if I look at this, it doesn't, in my opinion, no, it is not. And the reason is the area of the bigger one is more than double the area of the smaller one. They made the width longer and they made the height longer, so it's going to double that. How could you improve the pictogram so it is actually represents the information? So this would be, we could keep the width consistent. That would be a great way to do that, consistent, only increasing the height that way. That way you're only increasing one thing and not making it look so much massive, so much bigger. Okay. All right. Number 3, what errors do you see with the following histogram? Well, it has the labels. The labels are okay. They're right next to each other. That looks good. What about the bandwidth? Is the bandwidth good enough? So 56.5. So let's just check them. So equals 69.5 minus 56.5, 13, and then we have 74.5 minus 69.5, and these should be all the way equal, all the way through. Well, there's a problem there. So we should know that the class bandwidth is different. The width is different. If we check all of them, you will actually find that the first and the last classes have a larger class width, and that is a problem. Okay, because it should be consistent all the way through. All right, number 4, the number of robberies in North Charleston, South Carolina is depicted in 2 different graphs below. Use these graphs to answer the following question. Which graph do you feel represents the data better? All right, so looking at this, if we look at A, okay, the axes start with 0. We're doing great. Okay, but if we look at B, it starts at 200, and that kind of throws us off. So I would say A. The main reason is the y-axis starts at 0, so it represents the whole graph, okay? If you lived in North Charleston, how concerned would each of these graphs make you feel? Personally, A, I would be okay with it. I mean, the robberies are going up, but I mean, not crazy amounts, but when I look at graph B, oh, it looks really scary. I'd be really worried. The change looks so much different or drastic. Looks so drastic looking at graph B. I don't know if I would want to move into this area. All right, so now approximate how many times large taller is 2016 to 2013, so in graph B. So looking at graph B over here, how many of these do you think can fit in here? Well, 1, 2, 3, 4, 5, 6, 7, about 8. So I would say about 8, 8 times taller, but really, it's only going to be, let's see, how many times more robberies were there actually? So I'd say this is about 210, and this one would be about 280. So to figure out how many more times, I would say 280 divided by 210, and you get about 1.3 times more. So about 1.3 times more robberies are actually occurring, but in the graph, it really looks like 8 times more. Okay, so that is a big problem. Number 5, the number of assaults in a city is depicted in 2 different graphs below. How many times more assaults were there actually in year 5 compared to year 1? So year 5 to year 1, again, I would definitely look at this chart. It kind of likes it, graph A, it starts at 0. So if we look at this chart though, it is zoomed in, so it's kind of easier to find those numbers. So year 5 compared to year 1. So year 5 right here is 265. So year 5 is 265 about, and then year 1 is about 215, I would say. And it's asking how many times more assaults. So year 5 divided by year 1. So about 1.2 times more assaults, or you could figure out the percentage by flipping that if you would like. Round your answer to the near answer to 2 decimal places. So if you wanted to fix this, we can go up here, round, right? There it is, comma 2. We're going 2 and 1.23. So 1.23 more times more assaults. All right, that is 3.5. Have a great day.